In part 2 of episode 14, I would like to talk to you about the geometric shape which is called a triangle. And a triangle is just a geometric shape that has three straight sides. So, because this is the only requirement, you can get triangles that look all kinds of different ways. Here are two examples of two different triangles, but you can also have a really wide one like this. You can do lots of different things. As long as the object has three straight sides, you are working with a triangle. So, for something that would not be a triangle, if it had more than three sides, like a rectangle, that is not a triangle. This has too many sides. Or if the sides were not straight, that would be also not a triangle. Now, when you are measuring a triangle, you can calculate the triangle's perimeter the same way that you calculate the perimeter of any shape. The perimeter can always just be found by adding up the total length of all the sides in your object. That is how perimeter can always be calculated because that is what the word perimeter means. Perimeter is just the total length of all the sides of the object, the total distance you would have to travel if you walked around the outside of the object. So if your triangle like this one had sides of length 4 and 4 and 2, the perimeter would just be 4 and 4 and 2, 10 units of perimeter. Now, if you are dealing with a very special kind of triangle, it is actually possible to find the length of the third side from the length of the first two sides. And the special kind of triangle for which that trick is possible is what's called a right triangle. A right triangle is a triangle where two of the sides meet at a right angle or a 90-degree angle. For example, in this picture, the vertical side here on the right and the horizontal side here on the bottom meet at a right angle. They make the same kind of angle as north and west. One of them is pointing straight up, and one of them is pointing to the left. They are at a 90-degree angle. They are at a right angle. If you are dealing with a triangle like this one, where two of the sides meet at a right angle, two of the sides meet at a 90-degree angle, this is a very special kind of triangle, which is called a right triangle. Now, when you are dealing with a right triangle, the two sides that meet at a right angle are called the legs of the triangle. So in this picture, this side here and this side here, both of these two sides, which are meeting at a right angle, these would be called the triangle's legs. And then what's left is this sort of diagonal line, the one that's across from these two. And this line also has a special name in a right triangle. This one is called the hypotenuse. The hypotenuse. The hypotenuse. When you are dealing with a right triangle, there is a very special relationship between the lengths of the two legs of the right triangle and the length of the hypotenuse of the right triangle. And that relationship is expressed in an extremely famous formula, which is called the Pythagorean theorem. The Pythagorean theorem in symbols is written as c equals the square root of a squared plus b squared. In this formula, we have three variables standing for three unknowns. The unknown called A is standing for the length of one leg of your right triangle. And the B stands for the length of the other leg of the right triangle. The C here stands for the length of the hypotenuse. So if you have the lengths of the two legs of your right triangle, you can use this formula, this process, to calculate the length of the hypotenuse. C is equal to the square root of a squared plus b squared. So for example, in this right triangle in this drawing, where I have a leg of length 3 and another leg of length 4, and I want to know the length of the hypotenuse, all I have to do is plug the two lengths of the two legs into this expression. So I would need to find the square root of the first leg squared. In my case, take 3 and square it. And then I would need to find the length of the second leg and square it. Then I would need to add those results together, and after all of that is done, I would need to take the square root of the result, moving from the inside of this expression to the outside of the expression. So following PEMDAS, 3 squared would come first, and 3 squared is 9. 4 squared would come second. 4 squared is 16. Following PEMDAS, the next thing would be the addition inside this expression, moving from the inside out. 9 plus 16 would be 25. And so the square root of 25 is one of the ones that we calculated earlier. The square root of 25 was the number 5. So in this picture, I can find the length of the hypotenuse just by applying this formula with these specific measurements for the legs. The hypotenuse would be exactly 5 units in this situation. Now that we know the lengths of all three sides of the triangle, we would be able to find its perimeter easily. The perimeter of this triangle would just be add up all of the lengths of all of the sides, which we now know are equal to 3 and 4 for the legs and 5 for the hypotenuse. So in total, that looks like 12 units of length to go all the way around the triangle. So that is Pythagorean theorem. Pythagorean theorem is a special technique to find this one sort of special side of the triangle, the hypotenuse, from the lengths of the other two sides. Now to finish up talking about triangles, we've talked about how to find the perimeter of a triangle, even for right triangles in a situation where one of the legs is unknown. Let's talk now about how to find the area of a triangle. Now, when we find the area of a triangle, the two measurements that we use are what's called the base of the triangle and what is called the height of the triangle. And when we talk about base and height, we basically lay the triangle down so that it is flat on the ground. And when we lay the triangle down so that it's flat on the ground, the length of this bottom side of the triangle is what we call the triangle's base. And if we have set the triangle down on the ground so that its base is on the table or on the ground, and then if we look at how tall the triangle is from the base to its highest point, that is called the triangle's height. So if you want to find the area of a triangle from its base and its height, then you can find the area of a triangle by taking the base, which I will call B for short, multiplying it by the height, which I will call H for short, and taking 1/2 times the base times the height. 1/2 of base times height is the area of a triangle. So for example, if someone says, what's the area of this triangle here with a base of 10 and a height of 4? All I would have to do to answer that question is take 1/2 times the base times the height. 1/2 of 10 times 4. And so if I did, for example, in the calculator, 10 times 4 cut in half, the result of that would be 20 units. 20 units of area. If I revisit that right triangle that we had a couple of exercises ago, where we had one leg of length 3 and one leg of length 4 and a hypotenuse of length 5, we can also find the area of this triangle. It has already been laid down on the ground, and if we look at the length of the side that's on the ground now, the length of the side on the ground is now just that 3. And if we then measure the height of the triangle from its base all the way to its highest point, the height of that triangle would be 4 units. So the area of the triangle in this question would be 1/2 times 3 times 4, which would be 1/2 of 12, which would be 6 units altogether.